is about arrangement and movement of the particle in a solid. So solid are the particles are closely packed together. In fact, they are touching each other in a regular arrangement. So the arrangement is pretty fixed. I'm not sure if you do this word in O level, but we call it a fixed lattice. It's a very regular array of the arrangement of the atoms or the particles or the molecules. Well, in this case, it's a molecule. And then as a solid, they only vibrate about their fixed position. So these are covered in your simple structure or matter back in lower secondary as well. Next bit is they want you to work out the physical state of ethanoic acid. So when you think about the temperature scale then, if this is 16.7 degrees Celsius, that is melting point. Melting point is solid goes to liquid. And then here you have 118.0 degrees Celsius. Where is 130? 130 degrees Celsius then. That is, so 118.0 is the boiling point. Boiling point is when it goes liquid to gas. Here, below the melting point is a solid. At the melting point, it changes from solid to liquid. Here to here is a liquid. Liquid. And then at the boiling point, liquid goes to gas. Higher than here is already a gas. I'm not sure if that makes sense, but it does to me, so I hope it does to you. So it's a gas because it already boils at 118 degrees Celsius, which is lower than 130.0 degrees Celsius. So you already boil before you reach that temperature, you're already a gas. Boiling point turns from liquid to gas. Next up, you have copper to sulfate chemistry. So you need to describe the arrangement. So this kind of questions, they always ask you to describe the arrangement and the attractive forces. So in terms of the arrangement, we know that we're talking about a solid. Okay, so you need to describe a solid. So how do we describe a solid? The ions are ordered. So you know how when we draw a packing of a solid, they are always ordered and really close to each other, right? Okay, so they are ordered and uniformly arranged in layers. Okay, so obviously we are talking about ions, and therefore we are talking about ionic bond as the electrostatic force of attraction. Okay, so ionic bond, that is the electrostatic, well, in fact every single chemical bond is electrostatic force of attraction, but for ionic bond is the electrostatic force of attraction between oppositely charged ions. Whereas when you have metals, you have the electrostatic force of attraction between the cations and the sea of delocalized valence electron, and etc. Yeah? So start off with butanoic acid. Draw the structure. You want to show all of the atoms and all of the bonds. So be very careful when you draw OH. You do not just write OH. There is a covalent bond there that you need to show. So 3 carbon, 4 carbon, and then OH. You see, display all bond. Okay, that's the most common mistake people will make, and once you make it, there's no turning back. Okay, cool. Next bit, you are in a liquid, so they just want you to think about the movement and also the arrangement of the particles in a liquid. So in a solid, they are essentially touching each other, close to each other, right? Okay, but in a liquid, they can flow So they flow because, so just think about your water. That's because the particles can slide over each other. Therefore, actually not therefore. So this is what happened at the atomic level. So what you see essentially is the liquid flowing. So liquid can flow. You can pour liquid out. Okay. So that's what you observe. But at the atomic level, this is what actually happened. In terms of the arrangement, so solids are held in a fixed position. Gases are extremely far apart, that there are no interaction between them. Liquid is somewhere in between. So it's particles not held in fixed position. You are free to move, but not so can move randomly, but still close enough to each other. So it's not as far apart like in between gaseous particles, but still close enough. Okay, so next up you are talking about this melting point and boiling point. So if it is minus 4 degrees Celsius, it is melting point. Boiling point is 166. So you don't necessarily need to draw this. I'm just drawing this so that it's clear. Where is 0 degrees? So 0 degrees Celsius is there. Melting point is solid to liquid. Boiling point is liquid to gas. So when you are somewhere in between, what are you? You are liquid. Okay, so at 0 degrees Celsius, you already, sorry, not you, I mean the at 0 degrees Celsius, which is greater than minus 4 degrees Celsius, that is the melting point. So it's greater than the melting point, but lesser or lower than 166 degrees Celsius, which is the boiling point. Therefore, it remains a liquid. So it already melted because you already passed the melting point, but you haven't boiled yet because you haven't passed the boiling point. Okay, so it remains a liquid. That should be pretty straightforward there. Now glass waste is melted and then you make into new objects. You got to talk about kinetic particle theory. You got to describe changes in movement and arrangement 1 and 2 when a solid becomes a liquid. So there's melting. Okay, the thing is, I will not go through this altogether. I can tell you number one will be it's probably easier if you have like a table, I guess. When you have a solid, when you have a liquid, when you have a movement, when you have arrangement. So you can outline the point about a solid movement there. So solid only vibrate about fixed position, limited movement, right? Okay, so great. So very limited movement, limited movement. How about liquid? So you know that liquid can flow, right? Okay, so what do we know? Liquid can flow. So when you go from solid to liquid, you can have particles can slide over each other. Therefore, liquid can flow. Just think about your water, it can flow. So we are talking about solid to liquid. So that is what happened there, solid to liquid. Okay, that's the movement. How about the arrangement? So in terms of the arrangement, so the solids are tightly packed. The particles are tightly packed. Particles tightly packed. Very ordered lattice structure. And then very ordered lattice structure, and then you become less ordered, with more space in between, the liquid particles. It's a very hand-waving kind of thing, yeah, okay? You should have probably write complete sentence, but I'm just drawing out the idea really is the movement and the arrangement of a solid, the movement and arrangement of a liquid. You gotta talk only not just solid, liquid like that, but it's about the change, because what happened when you change from a solid to a liquid, yeah?